Still Pelumi. Then this class is for mathematics for SS3. Like I do advise that let SS2 also watch SS3. By the time they get to SS3, it's going to be sort of what revision for them. So theory of logarithm. Now we said there is strong relationship between logarithm and indices. There is strong relationship between them. So let's now look at the one that I call the general rule. The general rule that binded logarithm and indices. Take for instance, we are given a raised to power n, which is equals to m. So like this is in indices form. Indices form. Then this indices form, if I want to change it to logarithm form, this power will come alone to the other side, while this a will serve as the base. But I will include the log there, serve as base of log. So it will be equal to log base a is equals to n, while this will be my main log. That will be my main log. So this is this in log form. Now let me give example. Take for instance, we all know that a raised to power 2 is the same thing as 100. Now let's put it in log form and see if it's going to work. So if I should say I want to put this in log form, like I said, this will come to the other side, while this will serve as the base, and this one will serve as the main log. So now my log now will be log 100 base of 10, which is equals to 2. Let's see if this one will give me 2. So this one will now be equal to log 100 is 10 raised to power 2 base 10. Now in log, the power will usually go to the front. So that will be 2 log 10, 10, which is equals to 2. And let's see, this will be 2 multiplied by the same base, the same log and the same base is 1 in logarithm. Can that give me 2? 2 times 1 will surely give me 2. So it's still the same. If we are given in log form and you put it in indices form, let us say log, let's say log 25 base 10. Someone just say maybe is equals to, let's say is equals to 3. I'm just giving it for instance. Now we have, I said log 25 base 10 is equals to 3. So this will move and this will be the power of this. So it's the same thing as saying 10 raised to power 3 will be equals to 25 according to this. I'm just saying this. I'm not saying maybe the theory is correct, but I'm just looking how to convert it. Then from here, we move to laws of what? Logarithm. Laws of logarithm. Like laws of indices, but they have little difference. So we have little differences. Number one, we call it multiplication law. So multiplication law, what does it say? It says log mn. I hope you know when I write mn, I mean n times n. It's the same thing as saying multiplication will change to addition, but in separate form, that is log m plus log n. So in logarithm, we can also reverse it, but in indices, it's not reversible. It's not reversible. In indices, when you have log m n, it will be log m plus n. But if you now have log m plus n, you cannot tell me is equals to mn. In indices, of course, it's not equal to. sometimes, majority of time, you can't reverse it. Because if I had this one, I say is equals to when I multiply them, no, it will not give me the same. But that we are not actually going for indices, so we are. Now let me give example under the first law. Give me example. We say we have log, let's say log 6 times 2. Log 6 times 2. Let's give it base 10. Let's say all base n here, since this one is variable or true. So this one will give me log 6 base 10 plus log 2 base 10. So, but note, it is not, and also, then note, also, we could have uh, log 32 base 10 plus log 3 base 10. This can also be written in the other side. I will say multiplication to addition can change to multiplication, can be log 32 times 3 base 10. So we can write it in this form too. So let's move on. 2 is called division law. This division law said that log n divided by n. So division will be subtraction. That will be log m minus log n. So this is what we have. So like I have, let me give example. Example under it. I have log, let me say, log 100 divided by log 50. So which will be log 100 minus log 50. Now let's go to the third law. We have the log, we call it power law. And this power law is when you say log n raised to power n, then your index has to move to the front and leave the remaining one outside. So it will be n log big N. So meaning that if I should have like log 10 raised to power 2, aside from the base, the base will still, let's say the base is y, the base will still be there. So aside from the base, so this power move to the front, so there will be 2 log 10 is 10. So number 3, we have equal, the law of equal log and base, or sometimes law of equal. So this is when the log and the base are equal. When the log and base are equal, it's usually equal to 1. Like indices that say anything raised to power 0 is equals to 1. So this one is when the log and the base are what? Equal. So like, let me give example under it. Let's say we have log 100 base 10. So this will be log 10 raised to power 2 base 10. So in this logarithm and this is the student should have power of putting number in index. Power of putting number in index. Say for instance, if you just say 125, they should know that it's 5 raised to power what? 3, right? So 5 times 5, 25, 25 times 5, yes, 125. So they should have, for instance, 81. You should know that 81 work with 3. And 81, I think, is 3 raised to power 4. I mean, yes, 3 raised to power 4. So they should also have the ability of, let me say 64. you should know that this work with 2. So and that's 2 raised to power I think 6. Yes, 6. So if once they can do this one often, it will ease logarithm and indices. So because I know that 100 raised to power 2, 10 raised to power 2 is 10 times 10, of course. So this one will come here as we do in the log, in the previous log. So that will be 2 log 10 10. You see that this equal log and base. So it will give us 1. That's 2 times 1, which is equals to 2. And that's why previously here, that is why we got this one to be 1. Some students might be wondering, how do you not get 1? This is because of the law that is behind this. Now we have another law that say it calls this what, let's say fraction base. We have fraction base law. This is when the base, this is log m, y raised to power x, when the base has what, uh, oh sorry, I wouldn't call it I say index base, sorry, fraction base, index base, let's call it index base. So the base is what raised to power, like the main one is raised to power here, and the power comes, what is it, the power comes to the front when we continue solving. Here the power of the base, if the base happens to have what, power, the power will also come, but it's going to come in fraction form, like this x will turn to 1 over x. It won't come like the one here will come nothing, it will come the way it is, but this one will come in 1. So this one is 1 over x log m base y. So meaning that the power here has already come to. So let me give example. For instance, we have log 2 base 32. Log 2 base 32. And this will give us log 2 base 32 is 2 raised to power 6. 2 raised to power 6 is raised to power 5. 64 is raised to power 6. Now this one will come to the front as fraction. 1 over 5 log 2 2. It will remain 2 2 here. So and this one will now be 1 over 5 multiplied by 1. This will be the same thing, like we said. And finally, I will have 1 over 5 as my answer. Or if I want to write it, is 1 raised to power minus, 5 raised to power minus 1. So if you've written any of this form, we have log 1 is always equal to 0. Log 1 is equals to 0. Let's for instance log 1, let's say base a, for instance. So the meaning of this 1 is that I can change this one to be log a raised to power 0 base a. This one I am changing to a. I'm changing it to a kind of log that is what, in consonant with this base. So a raised to power 1 is the same thing as what, 1. I am replacing it. Now let's solve this further. Like we have known that the power will move forward, so is 0. We have is 0 log AA. So a 0 times the same base and log will give us 1. So this is 0. So you know that log 1 is what? Is 0 naturally. Addition and subtraction of logarithm. I'll still come with different examples on the. So let's add if you want to add logarithm, it is important that you know that you can only add the logarithm that are the same base and the same base. Take for instance, I can add 2 log, let's say log 2 base 3 plus 3 log 2 base 3. Since they are the same thing in this aspect, it will be easier for me to. That's why if you are working, you work towards them having the same thing. So this one now, if I add, is going to give me 5 log 2 base 3, because this one and these, they are the same thing. So I can also subtract. If I have 5 log, let's say 5 base 10 minus 3 log, let's say 5 base 10. So this one I can subtract it to be 2 log 5 base 10. Now let's now go to general working. You can say simplify. Solve this. It says simplify log 54 base 3 plus log 15 base 3 minus log 10 base 3. We have equal base, and that will give us the leverage to apply our first and second law. This is addition. We turn the addition to multiplication. This is subtraction. We turn our subtraction to division. So we take 1 log, of course, and it's going to be base 3 since everything is in base 3. So this one will now be 54 multiplied by 15 minus this one will now be divided by 10. Of course, this one will still give us log. Then we can now cut, I said, let me see, 54. We can now divide, I think 5 here, 3, 5 here, 2. 2 here, 1, 2 here, I think that's 2, 7. So this one will now finally give us log 27 times 3, I think that is 81. So like I said, the student must have ability to raise this to power. This is the same thing as 3 raised to power 4. So the base is still there. And finally, it will give me, like I said, the power will come front. That's 4 log 3, 3. And that is 4 multiplied by, this the same base will give me 1. And finally, I will have 4 as my answer. This is another example. Simplify log root 8 divided by log 4 minus what? Log 2. When you see questions in mathematics student, don't be scared. Just look at all these laws and apply them. And mathematics need constant practice. Then it will become part of you. Simple. That's how mathematics is. Very, very simple. So let's move. This one will give me the one on top now at the numerator. Log 8 is something as saying 8 raised to power half. That's the meaning. Divided by, of course, this one is log 2 raised to power 2 minus what? Log 2. We can continue by saying this one, the halfway, I will not even let the half go. I must raise this to power. That's why I say ability to raise it. This one can be raised to 2 raised to power 3. Of course, whatever is here, this one means, this bracket means multiply by this. So this one is power, this one is power. I will now multiply the 2. Now this one will come to the front. Of course, this my 2 will come here to be 2 log 2 minus log 2. Now, if you look at this, I'll multiply this. So it will give me log 2 raised to power 3 over 2 when I multiply this. So all over. If you watch this one clearly, you notice that it's log 2 log 2. It means I can subtract. This is 2 log 2. This is 1 log 2. So if I subtract it, it will give me log 2. That's 1 log 2. Like 2 minus 1. So this one will come to the front. So it will be 3 over 2. I mean all this come to the front. So we'll now have log 2 here over what? Log 2. Log 2 can cancel log 2. Finally, my answer will be 3 over 2. I'll better still 1 over 2. Now, let's still look at one more example. Is NECO question. So for SS2 and SS3, it is advised that majority of our examples should surround WAEC, NECO, GC, so that at least we'll use those questions to expose them. Practicing on past question alone is nothing, but knowing the rudiments and the law of guiding it. So even though if you are in exam, you are unable to finish it, at least you get it to crucial parts where you know mathematics deal with steps where you score larger percentage of the mark. Even though the mark is 10, you may end up scoring 8. Just maybe because the end you couldn't finish it. So let's move to simplify this. It looks jam-packed, but there's no problem. Let's just apply the same law. But first, let's look at this. No problem with this. But this one has 2 in front, so let's tell him to go back to his place. Normally it stays here. Because I want to do this addition. I want this and this to be divided according to the second law of division. Then this one is okay, there's no problem. So I'll now say is equal to log 75 over 10. This minus log 5 over 9 all squared. That is the work of these two. So plus log 100 all over 230, 243. So like this, we have done well. So let's go, let's apply it. This one will be division. So that will be 75 over 10 log 10 divided by 25. No, 5 squared. 9 squared will be what? 81. So why dividing? No, I don't need the bracket now. So this one is, this plus will be 10 multiplication. 100 over 243. So I can go ahead saying log base 10. I don't advise students to start dividing where you just apply a particular thing. You rewrite it, then you can now do your cutting. And also, this is division. To change to multiplication, then this will reciprocate. So it's going to be 81 over 25 multiplied by 100 over 243. So here now, since multiplication is in between, any numerator can cut what? Any denominator provided. 25 here 1, I think 25 here 3. Yeah. So we can still have the 0, cancel this is 0. This will remain 10. So we have this our 3 here. Our 3 can do something here. 3 in 24, I think that is 8. Here 1. So 81 cancel 81. Wow. We have everything gone except 10. So that's log 10 base 10. Of course, our answer is 1. You see, it's very, 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 very easy. Very easy. To be the assignment, evaluate log this, and this. So subsequently, I will be bringing in the sort form, as sort will be the next topic. So see you till then.